While we're on Hello World, I thought we would explore a couple of the differences at different optimization levels. We just looked at optimization level 0, and here is optimization level 1. So concretely, what are the differences? Well, it helps to stick it into a differ. So we're putting it into a program to show us the diffs, and so these things are highlighted as disappearing and going into nothing over here, and this is highlighted as a change rather than a deletion. So what are our first deletions? Well, this is the storage of the frame pointer to the stack and the movement of the frame pointer, and this is the reloading of the frame pointer. So the optimization level 1 does not use the frame pointers, and it just gets rid of that code straight up. Additionally, we see it removing that stray NOP that we don't really know why it's there, but it doesn't need to be there, and so it is removed at optimization level 1. Now, I did look up why that NOP was there because I thought maybe it was being used like some other architectures, and I found this post from 2019 by Jim Wilson, a GNU toolchain developer since 1987. So he gives some good description of what's going on here, and he says the NOPs emitted by GCC at optimization level 0 are more of a historical artifact of implementation. These NOPs are not emitted at 01, we just saw that. The NOPs may be emitted if we have a source line that no code needs to be emitted for. We emit a NOP so that we have some place to attach the line number info with -G. -G is like the -GGDB, which we use in our code in order to tell it to create symbols for GDB. The NOPs may be emitted if we have a node in the control flow graph that has no code in it. The NOP is emitted so that the simplifying the control flow graph won't cause the basic block to accidentally disappear. So again, I sort of mentioned before that rote compilation of very simple code is going to have to do with the changing of abstract syntax trees and graphs that compilers do behind the scenes, and they just try to have, at simple levels of optimization, at no optimization, they just try to do one-to-one replacement. And as it says here, this stems from the design decision that the code emitted at optimization 0 should be simple, quick, and easy to generate. And it should be easily debuggable, and that adding -G should never change the code emitted by GCC. So that is our little mini mystery about the NOP, and it's just to say that it is not being used for like a delay slot as you may find on other architectures. The NOP is just there because GCC has various historical artifacts of its implementation, which are now being applied to RISC-V as they added it. And then there's one last change between optimization level 0 and 1, and that is the change in this add eyes constant. So it was 32 here and it's 28 there, and that really just boils down to the fact that this add eye is a WPC 0, which means it's getting the PC and then it's adding a constant to it to go find some string in this case, the string for hello world. And that string is going to be stored after the code, and so it's just calculating a pointer to the string, and because the code got smaller, the pointer to the string is less distance away.